Hello, in this video we will solve this system of equation and we will see how we write infinitely many solution. Every time you solve a system of equation using starting with augmented matrix and using elementary row operation, if you end up with one of the rows, all of them zeros, then you have infinitely many solution. And so to see one example, we choose this system. We wrote down first elementary augmented matrix, and I see there is a 1 in here, and for that reason, since we always need 1 0 0, I'm gonna just switch these two rows. So I'm switching the row 1 with the row 2, first and second. So here we switching them, and then the second step is that now that we have 1, I need 0 and then 0 here. So if we need a 0 at instead of -3, what we do is multiply 3 by 1, by the row 1, so become 3. 3 minus 3 becomes 0. So we do this operation first. 3 times row 1, add to row 3, and the result you store it in the last row. And the next step is I need a 0 here. So if I need 0 here, I multiply -2 here, times 1 is -2, plus 2 is becomes 0. And so when we do the same, -2 times 0 is still 0, it's -3. -2 times 3 is -6, -9, -15. -2 times 2 is -4, -5 is -9. And now the next step is that now that we have 1 0 0, we need a 0 in here. Right here I need a 0. Well, if I need 0 here, I might multiply 3 times here, add it to this one, and the result store it in the row 3. So 3 times 1 is 3, minus 3 is 0, move it here. 3 times 5 is 15, minus 15 is 0. 3 times 3 is 9, minus 9 is 0. Now I end up with the third row, all of the terms are zeros, and that's why we have infinitely many solutions. But before we start writing the solution, I see 3, 15, 9. I could simplify this by reducing it, taking row 3 divided by R3, and the answer is going to be 1 0 3 2 0 1 5 3 and then 0 0 0. So what does it tell me? The last system here, this matrix, it tells us that y plus 5z equal 3, y plus 5z equal 3, and then x plus 0y plus 3z equal 2. So I'm writing, going back to this matrix, I'm writing it with the variables x, y, and z. And if we let z equal to some variable, maybe t or c or whatever variable you choose, we substitute t in here. Instead of z, it's become t. So x equal 2 minus 3z. But since we said let's make t equal to z, x equal 2 minus 3t instead is one solution. How about the y? So from here we know that y equal 3 minus 5z, but instead of z I'm gonna call it t because that's the parameter we choose. So the solution to this system will become 2 minus 3t, that's for my x. The y is 3 minus 5t, and then for the z we call z equal to t. And this is how we write infinitely many solutions. I hope this was helpful.